Good morning. Today let us solve 31st problem. We'll read 31st problem. Two charges attract each other with a force of 4 into 10 to the power minus 6 Newton when they are 0.4 meter apart. When their distance of separation increases to 0.6 meter, find the force between them. Okay. Two charges. Two charges attract each other with a force of, case 1. Let Q1 and Q2 be the two charges, Q1 and Q2, separated by distance 0.4 meter. Then they attract with a force of 4 into 10 to the power minus 6 Newton. Okay, we will write expression now here. F equal to 9 into 10 to the power 9 Q1 Q2 divided by d square. So F, we will substitute the values. 4 into 10 to the power minus 6, 9 into 10 to the power 9. We don't know Q1 and Q2. We will keep as it is. And distance is 0.4 square. Okay. Next, 4 into 10 to the power minus 6. So this, I take this side. It will be 16 into 10 to the power minus 2 divided by 9 into 10 to the power 9. Q1 into Q2 equal to. Okay. Now simplify this. 4 into 16 divided by 9 into 10 to the power minus 6 minus 2 plus 9 minus 9. So Q1 into Q2. Therefore Q1 Q2 equal to, we will substitute, simplify this. 4 into 16 divided by 9. 4 into 16, 64 divided by 9. 7.11. 7.11 into 10 to the power minus 8 minus 9 minus 17. Okay, we will call this as equation 1. Next, case 2. Case 2, the same two charges, Q1 and Q2. Distance is increases to 0.6 meter. Then what is the new force ಅಂತ ಕೇಳಿದರು. Okay, we will write new force ಇದಕ್ಕೆ F dash ಅಂತ ನಾನು. F dash is equal to 9 into 10 to the power 9 Q1 Q2 divided by 0.6 square. So Q1 into Q2, how much we got? 7.11 into 10 to the power minus 17. So F dash is equal to 9 into 10 to the power 9. So Q1 into Q2 is 7.11 into 10 to the power minus 17 divided by 36 into 10 to the power minus 2. Okay, 9 into 7.11 divided by 36 into 10 to the power 9 minus 17 minus 2. If it comes to the numerator, it will become what? Plus 2. Okay. So now we will calculate this. 7.11 into 9 divided by 36. So 1.77. New force 1.778 into 10 to the power 11 minus 17 equal to minus 6 Newton. This is the new force. Obviously, if distance increases, force reduces. So when distance is 0.4 meter, force is 4 into 10 to the power minus 6. When distance increases to 0.6 meter, new force is 1.778 into 10 to the power minus 6 Newton. This is 31 problem. Next 32. two point charges plus q and plus 4q are separated by a distance of 0.12 meter. Where should a third point charge minus q be placed between them so that it is in equilibrium? Okay. This is plus q and this is what? Plus 4q. Separation is 0.12 meter in air. Okay. So I'll place, so this I call as A, this as B, this I take as O. At O I'll place minus q from x distance from plus q. Let minus q be placed at a distance x from plus q so that it is in equilibrium. Okay, if it is x, then this will be what? This is x, then this will be what? 0.12 minus x. This plus q exerts force F1 and this plus 4q also exerts force F2. F1 and F2 are on the same straight line but in opposite direction. Therefore, F1 plus F2 will be what? 0. Or in equilibrium, F1 is equal to F2. Now we will write expression for F1. 9 into 10 to the power 9 q into q divided by x square. This side will write 9 into 10 to the power 9 q into 4q divided by 0.12 minus x whole square. Okay, this q cancels, this q cancels, this q cancels. 9 into 10 to the power 9 cancels. Okay, so I take here 1 divided by x square equal to 4 divided by 0.12 minus x whole square. You take this side. 0.12 minus x divided by x. This is whole square equal to 4. Square square root ಆಗ್ತದೆ. 0.12 minus x divided by x equal to square root of 4. 0.12 minus x divided by x equal to 2. Take 2x this side. 0.12 minus x equal to 2x. Minus x take this minus x this side. 0.12 equal to 2x plus x. 0.12 equal to 3x. We want x. Therefore, x is equal to 0.12 divided by 3. So, x is equal to 0.4. 0.12 divided by 3. 0.12 divided by 3. So 0.04. 0.04 meter. Okay. So therefore the third point charge minus q be placed. Result we will write. The third charge minus q be placed at a distance 0.04 meter from plus q so that it is in equilibrium. This is 32 problem. Next 33. 2-point charges when separated by 0.6 meter in air repel each other by a force of 20 Newton. If the sum of 2-point charges is 60 microcoulomb, calculate the individual charges. Okay, 2-point charges. Q1 and Q2 separated by 0.6 meter. Force 20 Newton given. F equal to 20 Newton, D equal to 0.6 meter. Q1 plus Q2 equal to 60 into 10 to the power minus 6 coulomb. Then calculate, then to find Q1 how much and Q2 how much. Okay, we will solve. Calculation. We use the formula F equal to 9 into 10 to the power 9. Q1 Q2 divided by D square. Okay. So F 20 Newton. 9 into 10 to the power 9. Q1 Q2 as it is. D is 0.6 square. 20, it will be what? 0.36 divided by 9 into 10 to the power 9 equal to Q1 Q2. Simplify. Therefore, Q1 Q2 equal to 20 into 0.36 divided by 9, 0.8. 0.8 into 10 to the power, this is plus 9. If it goes to numerator, it will become what? Minus 9. So means Q1 into Q2 equal to 0.8 nanocoulomb. So this is equation 1. They have given what? Q1 plus Q2 equal to 60 into 10 to the power minus 6 coulomb. Now what to do? So we'll substitute. Here you make Q1 equal to 60 into 10 to the power minus 6 plus Q2 will become what? Minus Q2. This is 2. 2 in 1. Okay. Q1 60 into 10 to the power minus 6 minus Q2 into Q2 equal to what? 0.8 into 10 to the power minus 9. You open the bracket. 60 into 10 to the power minus 6 Q2 minus Q2 square equal to 0.8 into 10 to the power minus 9. You take this side. Q2 square minus 60 into 10 to the power minus 6 Q2 plus 0.8 into 10 to the power minus 9. So this is minus. If it goes this side, it will become plus. This is plus, it will become minus. This is as it is, equal to 0. Now this is a quadratic equation. You solve. So Q equal to you will get here. Q2 equal to you will get. Substitute in either equation 1 or 2. You will get Q1. So this is homework. Okay. 33. Next 34. Read 34th problem. The force between two charges 10 nanocoulomb and 30 nanocoulomb separated by certain distance has a certain value. Find the charge to be added to larger charge to reduce the force to 1/4 time the original value. Okay. Here also two cases. Case 1. Case 1. The force between two charges Q1, Q2 separated by certain distance has certain value. Okay. F equal to 9 into 10 to the power 9 Q1 into Q2 divided by D square. Okay, F equal to 9 into 10 to the power 9. Given Q1 is how much? 10 nanocoulomb. Q2 is how much? 30 nanocoulomb. Distance we don't know. Plus 9 minus 9 cancels. 10 nanocoulomb it is. 9 into 10 into 30 into 10 to the power minus 9 divided by D square. So F equal to 9 3s are 27, 2 zeros into 10 to the power minus 9 divided by D square. Or you can take F equal to 27 into 10 to the power minus 7 divided by D square. We will call this as equation 1. Now case 2. Find the charge to be added to larger charge. So here see Q1 is 10 nanocoulomb, small it is, smaller. Q2 is 30 nanocoulomb, larger charge. Okay, they asked find the charge to be added to larger charge. So means Q1 will be as it is 10 nanocoulomb. Q2 will be 30 nanocoulomb plus Q I take. Something is added to this larger charge so that the force reduces to new force. F dash is equal to 1 by 4 times F. This is given. So to find is what here? Q we have to find. Okay. So now we will write expression for F dash. 9 into 10 to the power 9 Q1 Q2 divided by D square. Okay. F dash equal to 9 into 10 to the power 9. Q1 is what? 10 nanocoulomb. Q2 is 30 into 10 to the power minus 9 plus Q divided by D square. Now this plus 9 minus 9 cancels. F dash is what? F divided by 4. Nine into 10 into 30 into 10 to the power minus 9 plus Q divided by D square. So now substitute equation 1. F is 27 into 10 to the power minus 7 divided by 4D square you take. 90 D square cancels. You keep this term this side, take 90 this side. 27 divided by 4 into 90 into 10. You take this is also minus 9. You make it minus 9 only. So take 2 zeros here. Equal to 30 into 10 to the power minus 9 plus Q. Okay, simplify this. 2700 divided by 360. 7.5. 7.5 into 10 to the power minus 9 equal to 30 into 10 to the power minus 9 plus q. Keep plus q this side, you take this side. 30 into 10 to the power minus 9 is taken this side. Therefore, q equal to 7.5 minus 30. In both what is common? 10 to the power minus 9 is common. So q is equal to minus 22.5 into 10 to the power minus 9 coulomb. So q equal to minus 22.5 nanocoulomb. So if we add this much charge to larger charge, then force reduces to 1/4. We are decreasing the charge here. If charge decreases, force also decreases by keeping the distance constant. Okay, 35th problem. Read 35th problem. The 2-point charges, one 4 times as strong as the other, are placed at a certain distance apart in air. The force between them is 0.4 Newton. When the distance between them is decreased by 10 centimeter, the force is increased by 0.5 Newton. Calculate the charge and their original separation. Okay, read. The 2-point charges Q1, Q2. Q1 equal to Q I take, Q2 equal to 4 times Q, are placed at certain distance D equal to D only in air. The force between them is 0.4 Newton. This is case 1. Okay, here this is case 1, we will write expression F equal to 9 into 10 to the power 9 Q1 Q2 divided by D square. We will keep F as it is, 9 into 10 to the power 9. Q1 is Q and this is 4Q divided by T square. Okay, we will substitute 0.4, 9 into 10 to the power 9, 4Q square divided by D square. Q square divided by D square keep as it is. Q divided by T whole square I take. These are taken this side. 0.4 divided by 9 into 10 to the power 9, 4. Zero 0.4 divided by 4 divided by 9, or if we keep as it is, 4 into 10 to the power minus 1 divided by 9 into 10 to the power 9 into 4 get cancels. Okay, 1 divided by 9 into 10 to the power 9, this minus 1 if we take to the denominator it will become plus 1 into 10 to the power 1. So Q divided by D whole square equal to, I take 1 divided by 9 into 10 to the power 10. Square is taken this side. Q divided by D equal to square root of 1 divided by 9 into 10 to the power 10. So it will be 1 by 3. Square root of 10 to the power 10 is 5. So therefore Q divided by D equal to, we get 1 divided by 3 into 10 to the power 5. Okay, this is equation 1. Now case 2. Case 2 is what? When the distance between them is decreased by 10 centimeter. Q1, Q2, D minus 10. 10 centimeter means it will be 0.1. D minus 0.1 meter. So here again we take Q1 equal to Q, Q2 equal to 4Q, distance D equal to D minus 0.1. Then the force is increased by 0.5 Newton. Calculate the charges and original separation. Okay. Simplify it. Okay. Q divided by D minus 0.1 whole square I take. So 5 into 10 to the power minus 1. 9 into 10 to the power 9 into 4. Five divided by 9. 5 divided by 9 divided by 4. Okay. 0.1389 into 10 to the power. This is plus 9. If it goes to numerator, it will become minus 9. Minus 1 minus 9 minus 10. Okay. So Q divided by D minus 0.1 equal to square root of 0.1389 into 10 to the power minus 10. So we will 0.1389 square root. So it is 0.373 I take into 10 to the power minus 5. So here equation 1 we will change little. Q divided by D equal to 1 by 3 means it is 0.333 into 10 to the power minus 5. This we will call as equation 1. Now equation 2. Equation 2. Q divided by D minus 0.1 equal to 0.373 into 10 to the power minus 1. This is equation 2. 1 divided by 2 we will do. Equation 1 is Q divided by D. It will be D minus 0.1 divided by Q. So equation 1 is 0.333 into 10 to the power minus 5 and it is 0.373 into 10 to the power minus 5. Get cancels, Q get cancels. D minus 0.1 divided by D equal to 0.33 divided by 0.373 equal to 0.892. You take this side. D minus 0.1 equal to 0.892 D. You take 0.1 this side and this one this side. D minus 0.892 D equal to 0.1. This is nothing but 1. 1 minus 0.892 equal to 0.108. 0.108 d equal to 0.1, therefore d equal to 0.1 divided by 0.108, therefore d equal to 0.1 divided by 0.108, 0.925, d equal to 0.925 meter. This is initial separation. Now we will find the charges. Substitute in 1. Equation 1 is what? Q divided by D equal to 0.333 into 10 to the power minus 5. You take D this side. Q equal to 0.333 into 10 to the power minus 5 into D. Okay. 0.333 into 10 to the power minus 5, D is 0.925. So for this we will multiply 0.333. How much we are getting? 0.308. So Q equal to 0.308 into 10 to the power minus 5 coulomb. Therefore the charges are Q1 equal to Q, that is 0.308 into 10 to the power minus 5 coulomb. That is, we can take it as 3.08 microcoulomb. And Q2 equal to, the relation they have given 4Q, that is 4 into 0.308 into 4, 1.23 into 10 to the power minus 5 coulomb, that is 12.3 microcoulomb. And initial separation. D equal to 0.925 meter. This is 35th problem. So remaining 36, 37, 38, 39, 40, 41. Still 6 problems are remaining, so that we will solve in the next video.